study about relation schema and instance. So you are familiar with schema and instance in the unit 1 itself, right? A schema means it gives the structure of the relation, right? So the structure of the relation is given by a schema, and data that is being stored in a relation at a point of time is called as instance, right? So database instance, it deals with the data that is being currently stored in the database at a point of time is called database instance, and schema defines the overall structure of the relation, right? So for example, let us have some attributes a1, a2 till an are the attributes, right? So a relation R is a set of attributes, right? So for example, the instructor relation, it contains the ID of the instructor, name, department name, and salary, right? So formally given sets d1, d2 till dn, a relation R is a subset of the relation d1 cross d1 cross d2 cross till dn, right? So the current values of a relation are specified by a table, right? So an element T of R is a tuple represented by a row in a table, right? So a row in a relation represents a tuple or a record, right? So relations are unordered. Some relations, the order of tuples is irrelevant, right? So tuples may be stored in arbitrary order, right? So here the tuples are not ordered, right? So it is not ordered based on ID, or it's not ordered based on the department or the salary details, right? So relations, there exists relations which are going to be unordered, and any relation we have this keys: super key, candidate key, primary key, and foreign key, right? So these are the 4 keys that are present in a relation. So for example, K is a super key of R if values of K are sufficient to identify a unique tuple of each possible relation R of R, right? So for example, ID and name are both super keys of an instructor, right? So using ID, I'll be able to identify all the instructors in a department, and similarly ID and name also can be used as a super key. So a minimal super key is called as candidate key, right? So super key K is a candidate key if K is going to be minimal, right? So here ID is going to be a candidate key because the minimal super key is going to be candidate key, right? So for example, name is a candidate key in a relation. So using name of a student, I'll be able to identify all the students in a relation. Maybe for some students, they may have the same name, right? Maybe in a class, 2 or 3 students, they may have the same name. Only for those students will be using both a roll number and a name to identify a particular student, right? So name can be a candidate key, right? And so candidate key is going to be a minimal super key, and a combination of keys that are used to identify all the attributes, all the tuples in a relation is known as super key, right? So you all know about the primary key. One of the candidate keys selected to be the primary key, right? A primary key is used to uniquely identify a particular tuple in a relation, and whenever you refer the primary key of one relation in another relation, it is known as foreign key, right? So you all know about candidate key, which is the minimal super key. Super key, it's a set of candidate keys that are used to identify a tuple in a relation, right? So primary key is used to uniquely identify a particular tuple in a relation, right? So if a particular attribute is taken as a primary key attribute, it cannot have It should have only distinct values for each and every record, right? And whenever you are referring the primary key of one relation in another relation, we call it as foreign key, right? So schema diagram for university database, right? So we'll deal with this once you study your diagram.